So this device we have here in front of us is just a regular Raspberry Pi Zero. This specific one is the 0W Wi-Fi and Bluetooth version 1.1. What this device allows us to do is it takes the USB input to this port right here, so OTG adapter, takes the USB input from our Logitech G920 wheel, does some magic in here, and then sends the signal out to our radio via PPM. So this thing has two micro USBs. You need a micro USB power adapter and an OTG adapter to hook up the wheel. The program that I developed is based on the Logitech G920. There are a few different kinds of Logitech wheels, but by far I think the G920 is the most popular. It's PC and Xbox compatible, and it just seems to be the most prevalent Logitech wheel. There are some other ones like the G27, G29, G923. There's other wheels, and I believe that they have different mapping. So not only will the mapping be incorrect, but they probably use different libraries, and it's super complicated on that side of things. But as far as this I have in front of me is concerned, it only works with the G920. If I had one of those other wheels in front of me, I could change the program up a little bit to allow it to work with those, but for now it only works with the G920. This wire here is a auxiliary cord. It was an old auxiliary audio cord, 3.5 millimeter. I chopped the other end off of it. I used a multimeter to figure out which one was, they call this a TRS, tip, ring, sleeve. And I used a multimeter to check the continuity from the in wires here and the tip, the ring, and the sleeve to figure out which one is the sleeve and which one is the tip. Those are the two that we need. Our tip here is going to be connected to GPIO port number 12 with a resistor in line. I used a 470 ohm, but they say you can use 470 to 1K ohm. The sleeve here is our ground, and that was connected to pin 6. So the ground's connected to 6. The tip is connected to 12 with an inline resistor. And I just added a bunch of hot glue on here just to make everything more durable, because that resistors inside that hot glue, and I just didn't want anything breaking off. Those wires are pretty thin, you know. Hot glue protects it, makes it more durable for transport. Now, I don't have this hooked up to the Raspberry Pi currently, or to an RC car or anything like that, but I'll just use this to show you the features. The trims, the steering trim, if you're driving along and you notice that your steering is not centered, the right paddle will adjust the trim right, the left paddle will adjust the trim left. If you happen to notice that they are not adjusting properly, if right's adjusting left and vice versa, you just hold both paddles for 3 seconds. You have to hold both of them, but I only have one hand. Hold them for 3 seconds or more and let go, and it will reverse your trims. Right should do right, left should do left. I've noticed the very first time you try to do any sort of reversing, it takes a couple tries before it works, but it does work. Then this B button here will do your steering reversing. If you hold this between 5 and 9.99 seconds, up to 9.99 seconds, and let go, it will reverse your steering. Anything greater than 10 seconds or more will reverse your throttle. I added, for those that have the shifter on the G920, channel 3 will be activated by gears 1 and 2 on the shifter. Gear 1 is the low range of that channel, and 2 is the high range. I haven't added any sort of reversing yet for that channel, but it's a feature that does exist. I wanted to use it for my Traxxas Emax, which has a manual selectable 2-speed gearbox. I also added these buttons here for channel 4. What they control is a winch. So this will pull the winch back in, this will let it out. They should function that way, but just like the shifter, I didn't add any reversing to this, so your mileage may vary. I guarantee you it'll work. I don't know if it'll work in the correct direction, but the features are all baked into the code. I have tested them and they work. Another feature that I added into the code is Expo. There is quite a bit of negative Expo on the steering and a tiny bit on the pedals. This makes the pedals a little bit more responsive at the very beginning of their travel, and it makes the wheel a lot more responsive in the center of its travel. I noticed that the first time I tried to drive an RC car with that wheel set up, it's got like 900 degrees of rotation, and a normal RC wheel doesn't. So it doesn't feel normal trying to drive such a fast car with such twitchy steering with 900 degrees of rotation. So that negative expo really helps to make it more controllable, but it does add a little bit of twitchiness to the steering. I'd rather it be twitchy than dull, though. One thing to note is that the G920, which connects through this OTG port here, needs a USB power source. The USB power source can be this Raspberry Pi, but you need a very, very good micro USB adapter. If you don't have enough amps on your micro USB adapter, you'll notice that your wheel will not connect. It will just sit there flashing a white light because it's not getting any sort of USB power. I did find this cable here online, which does like a power data split. So you can plug one of the USBs into here. This one you could plug into a high amperage USB charger, like a power charger brick. And then this one you could plug into the G920. And what this will do is it'll inject a higher power USB power into the G920. It should resolve any sort of power issues that you're having, but I've had no problem with just a good micro USB power source on the Pi itself. All right, as far as loading the code onto this device, it's done through this SD card here. You don't need a 64 gig, even an 8 gig should work. Now, I installed Raspbian Bookworm Lite, I believe the OS was, and then I SSH'd into the Pi and did all of the code that way through my PC wirelessly. You do not need a Raspberry Pi W, a wireless Pi. You can get the cheaper model. You just won't be able to SSH into the Pi like that. You'll have to actually use a keyboard, mouse, and display. I'm going to try, for people that don't know how to follow the GitHub, and I used to be one of those people. It was difficult for me to even follow instructions on doing command line type stuff. I'm going to try to copy this entire OS, have it available as a download so you can pull the entire file, write it to the SD card, and go. You won't have to do any command line stuff. I don't know when I'll be able to get to that, but I'll try to get to it soon. As far as loading it yourself, the GitHub link will be in the description. There is a PDF in there that explains how to do it step by step, and you shouldn't have any issues if you follow that. If you do have any issues, go ahead and comment down below, and I'll try to help you as best as I can. I'm going to go ahead and include some footage of me driving with this setup on the G920. I don't have a whole lot of footage yet, but I do have a little bit. Enjoy.
This kid's crazy. Oh no.
I wanted to finish this video off by explaining that I'm done with this project. It is finalized. It works how I want it. I don't want to go any further with it. I could refine it more. I could add more features. However, I'm going a different direction. So, as you know, this uses a auxiliary cable and connects into the radio, and it uses PPM. The issue with that is the PPM frame timing does add some latency. Now, this latency isn't a game breaker. It's not a deal breaker for me. I found the car very controllable. However, if you were going to be driving a very, very fast RC car, it's definitely going to be a little bit noticeable. It's not going to ruin the experience, but it will definitely impair the experience to some extent. I have found that I can bypass the radio completely. The thing that I need to do that is the transmitter module. I have ordered an Express LRS transmitter module that I will connect directly to the Raspberry Pi using Crossfire protocol, which is significantly faster. It should cut the latency down significantly. Not only will it cut the latency down, but it will cut the cost because you don't have to buy a $150 plus radio. So keep an eye out for that video in the future. I've already developed the code. I just need the module to test it on. I'll be using that setup to test some higher speed cars like my Traxxas Nitro Rally build I posted in another video. Check that one out if you're interested, and please subscribe.